Okay, so we begin with the first chapter, kinetic particle theory. Now, for kinetic particle theory, you have all these different kinds of subsections where you are required to know the states of matter. States of matter is basically the properties of what is happening in a solid, liquid, and gas. For kinetic particle theory is how the particles actually move around their arrangement and their movement. And of course, how based on kinetic particle theory, there is the changes in the movement and the arrangement of the particles. And last but not least is diffusion, the movement of the particles from one area to another area. Now, matters refers to a substance that has mass and occupies space. In your primary school education, you have actually learn these particular properties in the form of, like, for example, solid, it has a definite shape, definite volume. Gas has no definite shape, no definite volume. And for liquid, you have no definite shape but definite volume. So there is three main states of matter. They exist mainly in the form of solid, liquid, or gas. Now later on, we will actually explore what is the process to convert a change of state of solid to liquid, followed by from liquid to gas, and vice versa. Now, when we look at the properties of solid, liquid, and gas in general, this is what we have learned in your primary school. But more importantly, for our syllabus in Sec 3 and Sec 4, there is something called compressibility. And in this case, the gas can be compressed only. For solid and liquid, they both cannot be compressed. Now, some of you may say that for liquid, I can actually compress it slightly. Yes, that is true, but in exam, please take note that liquid cannot be compressed, as that's the only accepted answer. Now, what is kinetic particle theory then? Okay, kinetic particle theory can be observed when you look at dancing dust particles around you. And what will happen is we can see these particles are actually moving in random motion. But how are we able to write it in the form of words? Now, kinetic particle theory comes in the form of two words, where there is the word kinetic and there is the word particle. Now, what is particle then? Particles are mainly made up of molecules. Okay, not only molecules but at the same time of atoms or ions. Kinetic means moving, okay, where things can actually move around. And hence the kinetic particle theory actually states that, let me get rid of this, yeah, okay, that all matter is made of tiny particles, which includes your atoms, ions, or molecules. And in this case, they are always in constant random motion. Now, it is important to have this particular phrasing here of having a constant and random motion, where this is the main gist or the main important concept of kinetic particle theory. Okay, and when we say constant, it means it is moving non-stop. Okay, whereas random means it is actually unpredictable. The line of movement is actually unpredictable. Now, a lot of students tend to just write constant, and that's not enough. You are required to include both constant and randomness in your answer. Next, these are four main sections in which you have to remember when you are explaining your answers. So 1 mark will go to every single section. For example, kinetic energy. You know, what is kinetic energy? It's the amount of vibration or heat energy that you obtain when the molecules are subjected to heating. Forces of attraction are the attraction forces that are actually holding the particles together. Okay, and based on how strong they are, the strength of the force of attraction, it will actually denote the arrangement, whether are they close together, and then subsequently that will actually result in the movement. Now, so for solid, how are you able to explain it? And look at the arrangement of particles, right? The particles are actually closely connected to each other, and they are packed like sardines in an orderly manner. Now, Why is this word orderly manner important? When we proceed to the next one, liquid, we realize that liquids are slightly closely packed, but they are in a disorderly arrangement whereby they are able to move everywhere. But for this, because they are closely packed, they are only able to vibrate about their fixed position. This means that the particle here will not be able to travel until here. Instead, it will just remain at its small little corner here and only vibrating about its fixed position. The forces of attraction is very strong. In what way? Because they're actually very close together, being in closer proximity with each other, the forces of attraction between the particles are actually very strong as compared to the particle from one end to another end. And because they are only able to vibrate about its fixed position, their kinetic energy of the particles is very low. It being having a fixed shape. Now, why does it actually have a fixed shape? Is because they are held together by very strong forces of attraction. What this means is that in between them, right, the force of attraction doesn't allow them to actually move around the container that they are being fixed at, and they are not able to move freely. A fixed volume, on the other hand, is that they cannot be compressed, as since they are very close to each other, there isn't much spaces where the particles are able to move into it, hence they cannot be compressed. Now for liquid wise, similarly like solid, they are closely packed. However, the only difference is they are in a disorderly and random manner. In this case, what we can observe is that this particle here, they are actually slightly further away from those of a solid, where the solid is just side by side. Next thing is they are able to slide over each other. Now, sliding over each other is very different from vibrating about its fixed position. What this means is that for this particle, it can slide past its partner or neighboring particles and move into another position of the container. The forces of attractions are strong, but they are weaker in solids, and because of them able to move from one area to another area, they actually have more kinetic energy than in a solid. So it does not actually have a fixed shape, and the reason is because they are arranged, they are held by weaker forces of attraction. Being held by weaker forces of attraction, this allows the particles to actually slide past each other easily, and hence they can move freely throughout the liquid. Now what this also means that if I give you a different shape of the container, the liquid will be able to change its shape to better fit to follow the shape of the container. Now, a liquid does have actually a fixed volume, and reason being is because they are still closely packed with minimal spaces in between for the particles to move in, and therefore they are actually also not able to be compressed. For gas, on the other hand, the particles are actually very far apart, and they are always moving randomly at high speed. Reason being is because there's so much space for it to move around, and of course the force of attraction is very weak as they are very far apart from each other. This results in the particles having a lot of kinetic energy, hence it can actually move at very high speed and in a random order. Just like the same explanation for the liquid, okay, the particles are actually very far apart from each other, this meaning that they have actually very weak forces of attraction. Having weak forces of attraction results in them having a lot of kinetic energy and hence can move in all directions. Just like the liquid, the gas can also take the form of the shape of the container that it is in, like for example the balloon and etc. Now, why does a gas not have a fixed volume? Reason being is because since they are actually very far apart from each other, right? There's actually space in between them, and if you apply the pressure, these particles can actually move into these empty spaces, and hence these particles can be compressed. So, in summary, these are the general ideas of the characteristics of a solid, liquid, and gas. It is important that you memorize this table, where this will actually um, may be able to come out as a potential O-level structure question where you are required to include all these keywords. Now moving on, we actually look at how the change in state of metals and the kinetic particle theory. So matter can change its states from one state to another, and these are the different kinds of processes for each to change its state. So from solid to liquid is by melting, liquid to solid is freezing, boiling will be involved liquid to gas only at the boiling point. Now if you see here evaporation, it can also change from liquid to gas, but the main differences between these two is that boiling occurs at the boiling point, where evaporation occurs at any temperature below the boiling point. And in addition, do take note that for evaporation, it only occurs at the surface of the liquid, where we will actually cover later on. And boiling occurs throughout the whole liquid. Last but not least is condensation from gas to liquid. And last but not least, sublimation, which is solid to gas, skipping the change of state to liquid. Now all these changes in states are reversible, and what we have learned previously is this is an example of a physical process. Okay, physical process is a process whereby there is no new substance formed, but there is actually mainly some changes, for example the change in state that is involved. For example, if you melt ice into water, the molecules of ice and water, they are actually still the same. It's still H2O. They do not form hydrogen or oxygen, which are new substances. Similarly, when you boil gas, you will only, from water, it will become water vapor, and it is still having the intact water molecules, which is H2O. Now, melting. This is how you go about explaining your answer in terms of when solid is melted at its boiling point. First of all, you have to include the particles gain sufficient kinetic energy. Now, how does it gain the kinetic energy? Is from heating. So heat energy is converted to kinetic energy in the particles, and this will actually result in the particles to vibrate faster. The particles being able to have higher kinetic energy and vibrate faster will then be able to overcome the strong forces of attraction holding the two particles together, and this results them in being able to break away from its fixed position. Now do take note here that this point is actually explaining the arrangement of the solid particles, and later on particles will then be able to slide over one another, and the solid has melted to a liquid. Now do take note that this section here is actually explaining the movement of the particles in a liquid state. However, in your O-level questions, how it will be phrased is something like explain how the particles change in state with respect to arrangement and with respect to movement. So when it gives a question like this, you are required to say what is the initial arrangement in a solid state, and after heating, what is the subsequent arrangement in the liquid state. Similarly, the movement in a solid state from vibrating about its fixed position to the movement in the liquid state, which is sliding over one another. Temperature curves can be represented by heating curves, and of course for freezing it will be called a freezing curve. Now for a heating curve, do take note that it does not necessarily have to start from a solid. It can actually start from a liquid. So do take note in the question, when you read the question, which state are they required to be at. Okay, so if we look at the solid state, what will happen is from A to B, the particles is in a solid state. Now do take note that over time the temperature is still increasing. Now solid doesn't become liquid immediately. Instead, it takes time for the solid particles to gain sufficient kinetic energy in order to overcome the forces of attraction. Okay, so at A to B, the solid is heated, and the particles gain kinetic energy. This results in the temperature of the solid to increase until it reaches point B and its melting point, and at point B the solid will begin to melt. So in the question, if they ask you to label what is the process from what's the state from A to B, you are required to give the solid state. However, A to B doesn't indicate melting. Instead, it's just heating. Now from B to C, the process here is actually melting. Why? Because over here at B is the melting point, as this will finally result in a change of state. Over at B to C, the substance actually has a mixture of states of liquid and solid. Okay. Now what this is usually indicated is by a horizontal straight line, and melting occurs at a fixed temperature. Now there is some variation in this if the substance is actually an impure substance, but assuming that it's a pure substance, it will only melt at a fixed temperature. Now this fixed temperature is usually given in the exam question, so do take note of, so you are required to actually read the exam question clearly. And energy from this heating is used to overcome the forces of attraction. That is why you don't actually see any changes in the temperature of the melting point. Reason being is because that this energy used, the heat energy used, is actually used to overcome the forces of attraction as compared to here. Okay, and this results in a steady horizontal straight or fixed melting point. And over here, if the question asks you what's the change of state, or sorry, what's the state that is present from B to C, it's actually liquid and solid. It doesn't matter if you write a plus or a dash, or is it a solid dash liquid. As long as you have both these keywords and a symbol to represent the two are actually together, you'll be fine. Next, we look at C and D. At C and D, okay, at point C, especially at point C, this is where all the solid has already melted. Okay, over here, all solids are still not melted. It's only after C that the solid has melted, and then you will slowly see a increase in temperature again. And this over here from C to D, it has already changed in state to liquid. Freezing goes in the opposite direction, where the particles will lose kinetic energy as lesser heat is supplied and will tend to move slowly. Now do take note, for this you are required to explain the form of the particles will slide over each other less slowly. Then the particles will start to settle into its fixed position, resulting in the particles being frozen in the solid. The cooling curve denotes this particular arrangement, where the explanation is also the same. From P to Q, particles in the liquid will lose kinetic energy. The temperature of the liquid drops to the freezing point, and Q, the liquid will start to freeze. Last but not least, a mixture of liquid and solid exists and the temperature remains constant. This is also having the same, now why is it so? It's the same explanation as what we have in the previous slide, where the energy from the but rather than heating, right, the energy is actually not used to overcome the forces of attraction. Instead, it is being lost. And so you have a constant temperature here, okay, as the bonds are forming. Next, from R to S, the solid will lose even more kinetic energy, and at R, the liquid will have been completely frozen to form the solid form. Now, boiling, on the other hand, is the change of state from the liquid to a gas only at the boiling temperature. And for this boiling temperature, we call it the boiling point. So, as you can see, it can also start in the liquid form. Explanations are always the same, where you know there's the gain in kinetic energy due to temperature. Remains constant because of the energy is being used to overcome the intermolecular forces of attraction. And then last but not least, at Y to Z, the particles will become into the gaseous states. Evaporation is the change from a liquid to a gas below the boiling point. And this can only occur on the surface of the particles as they have enough energy to escape as a form of gas. So volatile liquids, the meaning of volatile means liquids that actually are able to become gas easily at room temperature. For example, your perfume or petrol. These are the main difference between evaporation and boiling, where the main one is for temperature, where boiling only occurs at a particular temperature. and evaporation occurs at any temperature below the boiling point. It is insufficient to just say any temperature. You have to include below boiling point. Condensation is the change from the gas to the liquid. So when the temperature drops, it will actually lose kinetic energy. The particles will move closer together. This will result in an increase in attractive forces of attraction, and the gas will become a liquid. So always remember the 4 domains of how to go about explaining your answers. Sublimation is the sudden change from the solid to gas, skipping the melting process. Now this is because these forces of attraction between the particles are just too weak to remain in that state. One very good example that we have actually come across is basically your dry ice. Now, diffusion. For diffusion, you are required to know what is the definition of diffusion and what are the factors that can actually affect the rate of diffusion. Okay. So these are some examples in which diffusion can occur. So how do we actually show diffusion then? Now, diffusion is the net movement of molecules from a region of high concentration to a region of low concentration down a concentration gradient, and this process doesn't require energy. So in this case, you can see that for bromine, it's located at the bottom and air is located at the top. By removing the gas, a paper cover here, okay, what will happen is diffusion can occur where the bromine molecules, which are highly concentrated here, will actually move upwards, and the air molecules, which are concentrated at the top, will move downwards, resulting in a mixture of bromine and air. Okay. So the movement is actually random, and that the bromine particles will actually spread out into the spaces in between the air particles. The gas will also be evenly spread. And we call this a homogeneous mixture of air and bromine. Homogeneous means it is equally spread in some way. Okay. Diffusion occurs due to the difference in concentration of the particles. For water molecules, diffusion should not be used. Instead, it should be osmosis, but that is not in your syllabus. Now, do all particles or gases actually diffuse at the same rate? It is very difficult to actually allow solid to diffuse. That's why most diffusion occurs at the gaseous state. Okay? Now, it is dependent on the mass of a gas particle, or what we can see from the periodic table, the molecular mass. The molecular mass will actually denote how big or how heavy the particle is, and having a much heavier particle or having a higher relative molecular mass for that particle will result in it having to diffuse at a slower rate. Okay, so the smaller the smaller the relative molecular mass, the lighter it is, and hence it's able to move faster. And being able to move faster, it will actually be able to diffuse faster. Now, how are we able to show this? We can perform this setup where over here, this wool is actually soaked in concentrated ammonia solution, and over here is by hydrochloric acid. Now, if you do take note that they both have different molecular mass. Now, how the molecular mass for ammonia is 17, while the molecular mass of hydrochloric acid is actually 36.5. So, if the theory holds, this particular molecule should be able to travel faster as compared to hydrochloric acid in this direction. So what this means is, what we'll expect is ammonia to travel somewhere here a lot faster as compared to hydrochloric acid being able to travel to the other end. So it will actually travel somewhere slower in this manner. Okay, and this can actually be observed when hydrochloric acid reacts with the ammonia gas. Okay, it will actually produce white fumes of ammonium chloride, and this will actually show that ammonia is actually lighter than hydrochloric acid in terms of diffusion. Now, this is a common MCQ question that comes out in O level, so do try to understand this particular example. Diffusion in liquids, okay, for example, potassium manganese 7 is introduced into the beaker, and this will actually form a very dark purple solution as compared to the top. When diffusion occurs, it will actually come and the purple potassium manganese 7 will actually diffuse to the the top layer to form a uniform purple solution. Now for this, if you want to speed up the reaction, you use a higher heat temperature, and this will actually result in the rate of diffusion to also increase. Now why is this so? This is because when temperature increase, the particles will vibrate faster, and if the particles are able to vibrate faster, it's able to move faster and hence able to travel or diffuse faster to the lower concentration region. And that is all for this chapter. Thank you.